All right, so we'll go over the warm-up shortly, but friendly reminder, I do not have time to reteach you all the stuff that you were supposed to have learned from watching the video that I made. So that is all on you. And really, I should have given the mid-unit quiz today, because that's what I promised you. So instead, I'll give you the rest of today to make sure that you're caught up on all the stuff from the past week, honestly. And then you're taking the mid-unit quiz tomorrow. And the mid-unit quiz is really from the beginning of the unit through lesson 10. So today we're doing lesson 12. So you really should be able to do everything already. But I know I entered all the missings in last hour. And yeah, I'm not going to update grades again until I have more time. So that's all on you. You guys knew when it was due. The note sheet, there's no reason it can't be turned in the same hour of the day that you had to do it, because you literally just copy the notes and you take a picture and upload it. There's no reason for that. I get like with the accuracy on the puzzle pieces, like I get how those might be like a little lower, but you know, no one asked me questions. I said I'd be checking my email. No one emailed me with any questions. So otherwise, that's all on you. Make sure it gets done. Because again, I don't have time to reteach those 3 lessons. They're already taught by me in those videos. Everything you need to know is in there. What else about that? We are testing for unit 6 before spring break, no matter what. So we have essentially this week and next week, and then it's spring break. So we're testing unit 6 next week. So be aware. The goal for lesson 12 is to see how numbers in expressions, and it says like, but I need to enter, it looks like there's like stuff missing. But in expressions like x squared plus bx plus c, what form is that, by the way? When it's ax squared plus bx plus c. They're not exponential. This is not. It's the standard form of your quadratic equations. Okay, so we're going to see how the numbers, which would be a, b, or c in that expression, affect the graph. So if by the end you can describe that in words and like visually the change, then you're good. So graphs, tables, and equations. I'm recording right now, but it'll be linked in the slides. Puzzle piece is lesson 12. And yes, we're taking the mid-unit tomorrow. And here's all the dates for the rest of how this unit is going. So we are testing next week by Wednesday. So questions on anything? All right, we had to adjust the study guide. Luckily, no one had even started it yet, so fine. I'll make sure that that is uploaded to Schoology soon and toward the top, like always. And then you can make sure that if you can answer all those questions, there's no reason you shouldn't get a good grade on your unit test. All right, so here's the warm-up. And this, I said, should be easy because it's linear equations. What format are linear equations in? Okay, good. If you didn't know that, write that down. So if it's linear, it's in that format. Are these equations written in that format? Yes. Even this one. The 3 minus x. It's still in slope-intercept form, even if you change the order, like you write the x term second. But as long as that y is alone, then it's in slope-intercept form. And because it's in slope-intercept form, it should be really easy to identify what 2 things. Table 2, what's one of the things I should be able to identify really easily in slope-intercept form? So y-intercept, because it is in what position? B. So B is for your y-intercept. It's the constant. So even though this is in a different order, it goes 3 minus x. I know that my y-intercept is 3 because it's the one that's alone, not the one that's in front of the x. Does that make sense? Table 7, what's the other thing I should be able to easily identify from slope-intercept form? The x.
Oh, wait, no. The slope.
The slope, which is the m, okay, not the x, but you know it's the slope because it's in front of the x. So that you guys would need to know, which hopefully you guys do by now, otherwise, now you know. Okay, so for equation A, this very first one, or line A, what equation best matches? Table 3. Which one of these do you think best matches A? Okay, we'll come back to you, table 3. Table 4, I'll ask you a different one. Table 4, which one best matches B? Come back to you, table 4. Table 5, which one best matches C? For the love, guys, because this semester one. Just re-broke it down over here. Okay, like there's no way no one in your notes doesn't know how to do it. Because none of these are even in like a different format. They're all in slope-intercept form. So and I'll come back to these 3 tables. You're not off the hook. I don't know what we were doing when we were doing the warm-up, but there's so many ways you can solve this. So many. Table 6, answer this question for me. Looking at this first equation, this one, what's my slope? Okay, good. So that means if my slope is 2, slope is rise over run. That means I'm going up 2 to the right 1. Which one could be doing that? Think about it to yourself because I still have to go back to the table and ask them. All right, which one? And then again, don't answer me right now. Which one looks like it could be going up to and to the right one? Table 7, tell me, what's my y-intercept in this one? It's 4. So then now think to yourself, which one could be crossing the y-axis at 4? Okay. I was more so asking you guys to think about it.
Come on.
But like, there's no way that this should be that hard. That 3 groups, you can't tell me an answer. So table 3, or actually, yeah. So this is basically what we're doing. Identify your slope and y-intercept for each, and then see which line would best represent it. So back to table 3, which equation best represents A? Okay, good. Because for that one, table 8, what's my slope for this one in the red? Nope, that's my y-intercept. So try again with my slope. Well, the x is not my slope. What's in front of the x is my slope. So what's in front of the x? a -1. So that's also the only one that has a negative slope at all. So either way that you look at it, the only possible one that this one could be is A, because it's the only one that even goes down. Down one to the right one. Down one to the right one. Make sense? And it goes through 3. So look how it's counting. It goes from 0, 5, 10, so in the middle would be 3. Question? Okay. So then, table 4, which one best represents B? We already figured out that one, so 50-50 chance. Ada Moffett. If you're gonna answer my question, you have to like listen and look at the question first. So table 4, what one does B best match? That is incorrect. So then by process of elimination, it must be that one. I know it's not this one because look, the slopes are pretty similar, so I'll give you that. But what's this one's y-intercept? -2. Is this in the negative? No. So I know it's not the other one, so by process of elimination, it must be this one. All right, and then when you look at it, we are going up 2 to the right one. Up 2 to the right one. Question? Okay. So then table 5, we kind of looked out what the C has to be then. Y equals 3x minus 2. It's the only one that has a y-intercept in the negatives. You could have known just based off of that. But also, yes, it does go up 3 to the right one. Up 3 to the right one. So questions on that? Kind of scaring me, not gonna lie. This is a semester 1 standard. This is slope intercept one. Now we're gonna look at this current unit, which is quadratics. What shape do quadratics make on a graph? Bob? A U-shaped graph. Good. So now we're not looking at just straight lines. We're looking at U-shapes, and they have a longer equation, or not necessarily longer, but a different type of equation. What's the minimum requirement for something to be a quadratic function? X squared. Good. Could you have other stuff around it? Yes. You could have an X term. So let me actually put it in Desmos. Also, side note, and I mean, I try to like not have you guys use Desmos for everything, but like that was kind of concerning. You could have also done the warm up by graphing it. So if you don't have a graphing calculator, I suggest investing in one, because Desmos is not on every single test. It's not on your ACT Aspire test. I can tell you that. So I suggest investing in a graphing calculator, and then that's how you could have answered the warm up too if you didn't remember slope and y-intercept. All right, but down here we're talking about quadratics. So yeah, the minimum requirement for a quadratic is x squared. Can you have other things and it still be a U-shaped graph? Yes, you can. Like you could have an x term. As long as it's not higher than squared, then it's still a quadratic. You could have a constant, right? And every little change that I make changes the graph. All right, so that's what we're going to be exploring today. So what you will do in your groups, and at the end of the time, I'll assign a reporter, but what you will do in your groups is fill out these tables. Feel free to use a calculator. In fact, please use a calculator. All right, all you are doing is filling this out. It tells you what x is. It even tells you what x squared is. Now you just have to take it a step further, figure out what x squared plus 10 is and fill it out for this row. What x squared minus 3 is and fill it out for this row. Same thing down here. So you have essentially 5 rows to fill out. All the expressions are there. There's no reason you can't use a calculator. Just make sure that if you are plugging in a negative number into your calculator, like for example, if I'm finding this one, -3 squared plus 10 should be entered like this, where the negative is in parentheses. Otherwise, it'll give you a wrong answer. Questions? All right, then get to it. If you don't have any clue how to do this, you better ask. Don't wait until I call on you to share your answer to say like, I don't know, because that's just a big waste of time. Since there's 5 rows, I'll give you 5 minutes to have those filled out. All right, so as I was saying, in each table you have what the inputs are. That's what this X row is. So all we're doing is different stuff to the X. So for example, the one that I circled is going to be -3 squared plus 10. And again, feel free to use a calculator, but just know you have to, when you plug stuff in, use parentheses or else the calculator may tell you the wrong answer. Because what is -3 squared? +9 is correct. There's no way you could ever square any number and get a negative. So that's why the calculator probably told you -9, but that's because the calculator isn't that smart. You have to be smarter than the calculator. So yeah, -3 times -3 is 9. Plus 10 is 19. Good. So then table 2, I'll kind of alternate between these 3. So Allison, what goes here where my mouse is? 14. Ryan, what goes here where my mouse is? Peyton, what goes Peyton, what goes here? Allison, Ryan, and Peyton. All right, class, agree, disagree? Anyone notice anything about what we did? Hayden?
The middle.
So the middle is this is, I don't know, a singular number, and then it's like the same numbers on each side of it. You guys notice that? That's usually a good indication that you're dealing with a parabola, a U-shaped graph, which is our quadratics. Good. Anyone notice anything else? Sorry, what was that? Okay, decreases and increases, so that supports the U shape, right? Goes down and then back up. Do you guys happen to know what a vertex is? You might have heard it in lesson 5 and 6, but I don't know that we've ever actually defined it. Landon? Good. So our vertex is going to be our turning point of the graph, just so you know. So that wasn't necessarily what we asked you, but for these, you can identify the vertex when it's like not having the same output. Like clearly the 10 is the Y of my vertex because it doesn't repeat. It's like only there once. And that X was 0, so that's my vertex for this graph. Okay. I didn't expect you to know that, but just so you know, you can identify your vertex that way. It's the one that has like the same numbers on each side. Anyone else notice anything about that row? Maybe compared to the row above it. Anything? Aiden? We're just adding 10s. So look at X squared. They already did that part for you. The only difference between here to here is that we're just adding 10. So then from here to here, Just adding 10 each time. I didn't even notice that first hour, but someone did, and I was like, oh yeah, that makes sense. I'm very like, just plug it in your calculator and see what you get, because that'll work every time. So questions on that? Okay, let's see. I think table 4, I said I'd alternate between you guys for this row. Making sure I'm on the right row. So then Christina, what'd you get for like this one right here? All right. Ada Moffett. Jordan. 2. Christina. -3. Ada Moffett. Jordan. And Christina. Okay. Class, agree, disagree? Do we see that same thing as before, like when we get to the middle, it fanning out like the same numbers? Almost, like the 6s are equally apart, but it looks like we have some differences in the positive or negative. So let's see. You can use a calculator for sure. But look at the x² row to this row. What's the only difference in the expression? We're minusing 3. So really all I have to do from this row to that row is -3. So from here to here looks good. Here to here looks good. Class was 1 - 3. We gotta put a negative there. 0 - 3 looks good. 1 - 3 looks good. 4 - 3 is actually what? We gotta fix that one. But otherwise, good. But yeah, if it's truly gonna be a U shape, then it needs to be like a middle point and like equal on both sides. And granted, you might have like part of the U in some problems, but in this one, my vertex is what for this one? Anyone know? So -3 for the Y, what for the X? 0, okay, because that's the X value when it becomes like, I don't know how else to describe it. When it's just one of the same Y's, not like 2 Y's that are the same, okay? So good. Moving below, I believe table 7, I said you'd have this row. Okay, well, let's see. Actually, before we do that, let's pause. So in number 1, all we did was either add a constant or subtract a constant, right? So B is saying what happens with it when a constant is added. And then also what happens when it's subtracted. So you can see it on a table what it looks like. You could say like the Y's get bigger, the Y's get smaller, whether you're adding or subtracting. Now look at it on a graph. So x² is the most basic quadratic function, right? We call this the parent graph because it's the most basic. Just like how for linear functions, the most basic would just be y = x, right? Any other variation of that is a change to the parent graph, right? So the same is true for quadratics, except for that it's x². So I'm going to leave my parent graph there. I'm going to show you that when it's x² + 10, what did we do to the graph? How did it change? So we went from the red graph to the purple graph. Did it go left or right? Did not move left or right. Did it move up or down? Which way? So when I add a constant, the graph moves up. So that's what you could write. When I add, graph moves up. When I subtract, let's see. So we're going from the red graph to the purple graph. What happened to the graph? What does subtracting do? Brings it down. Specifically, whatever the vertex is, just bringing it down, which of course then brings down everything else. So to summarize that and answer that on your paper, because that's like why we do this, this is why it's important. When you add, the graph moves up. When you subtract, the graph moves down. They love to put those types of questions on your test, like how does f of x transform to g of x? What would I need to add or something like that? Well, if you're adding, it would be for it moving up. If you're subtracting, it would be for it moving down. Questions on that? Okay, so now we're going to see what happens when we multiply by a number greater than 1, by a negative, and by numbers like between 0 and 1. So let's see. I already asked you to do this, so hopefully you have this filled out. So table 7. We can start with Anthony. What goes here where my mouth is? Okay, Sierra. Abigail. 0, 2, 2. Okay. Anthony. 0. Sierra. 2. Abigail. 8. And Anthony. Okay, class, agree, disagree? Okay, so really just plugging it in, right? If you plugged it in your calculator and you got the correct answer, it would look something like this, right? Put in parentheses. But yeah, so -3 squared is 9. 9 times 2 is 18. Also, what's the only difference from this row to that row? Sorry, what's the difference? So yeah, doubling, multiplying by 2. So really, they did the x squared for you already. Just had to times that by 2. But either way, same difference. All right. Let's see. I don't think I assigned anything else to other tables. So I'm just gonna kind of call on you. You give me what I asked for. So Peyton R, what goes here where my mouse is? 4.5. Ian, what goes here where my mouse is? Peyton C, what goes here where my mouse is? 0.5. All right. Let's see. Hayden Moore, what goes here where my mouse is? Wrigley, what goes here? Abigail G. And Mary Angela, what goes here? Okay, good. So I'll see if they're right in a second, but we do have it where there's like a middle and then like the same numbers equally apart. Yeah, what's the only difference from my parent graph to this row? It's cut in half. So really all you have to do is take this x squared, cut it in half, and it looks good. So good job. And then the last row, so Julian, what goes here where my mouse is? Okay. Abigail A. Let's see. Hayden, what goes here? Brooke, what goes here? And Landon, what goes here? Oh, you want to change this to -8? Okay. Landon, you awake? What goes here where my mouse is? Okay, and I think at this point, everyone has answered, so as a class, what goes here? And what goes here? Okay, good, now, if you look between. Well, we could look at the parent graphs for that one, but if you look at this one, these are really similar, the only difference is. In the last row is multiplied by -2, so then it would make these negative. Questions on that? All right, now let's see what it looks like in Desmos, because we can see it on a table, kind of. I think it might be more clear in Desmos what the transformation is. So here's my parent graph, still in the red. Now here's the 2x squared. So did the graph move up or down? We're going from red to black. So just tell me, did it move up or down?
Yes.
Actually, neither. It did not move up or down. A good place to look at would be the vertex of each. Okay, vertex is still in the same spot for both. So it did not move up or down. Did it move left or right? No, it did not move left or right because vertex is still in the same spot. But they're not right on top of each other, right? How would you describe these two graphs compared to each other? Which one is more narrow? The black one, the one that's multiplied by 2. It gets more narrow. We'll summarize this here in a second. See what happens when we change that 2 to 1/2. What happened to the graph? Like visually, how did it change compared to the parent graph? It became wider. Now see what happens when we multiply it by the -2. What changed about it? It is like a mirror. It's reflected over the x-axis. What else about that? Is it the same width still? It might be harder to see when it's flipped and not right on top of each other. It is still more narrow. Okay, so multiplying it by a number that is absolute value is bigger than 1 makes it more narrow. What makes it flip is the negative. Okay, so the negative makes it flip or reflect. And then multiplying it by a number between 0 and 1 makes it wider. Okay, so we're going to summarize all that right here. Because this says when x squared is multiplied by a number greater than 1. So when I write these rules, I'm going to refer to standard form. What are we changing each time in this table? The A, B, or C? The A. So you can summarize it as when A is greater than 1, the graph vertically stretches. And then in parentheses, I'm going to put more narrow because I think that's more friendly terms. But if it says vertically stretched, it means more narrow. Now, I'm also going to add this to our signs right here. I'm going to put these bars around it. You guys know what these bars are called? Yeah, anyone? They're not parentheses. They do group it, but they're not parentheses. What did you say, Ryan? Okay, good. So add those to this. Absolute value of A is greater than 1. Because as you noticed, when it was -2, the graph was still more narrow. All right. Do you remember what absolute value bars do to numbers? So like, what's the absolute value of -2? 2. What's the absolute value of +2? Actually, it's 2. So absolute value bars make the number inside positive. Because absolute value is like how far away is it from 0. So that's why even when it's -2, the graph is still getting more narrow because the absolute value of -2 is still greater than 1. Does that make sense? So that's why we're adding it to that definition. All right, when A, and we're gonna put the absolute value of A as well, is less than 1, the graph vertically compresses, which is like math talk for saying that it gets more wide. But they do use that wording, like they'll say, which one shows a vertical compression? Well, you're looking for the one that would make the graph wider. All right, so basically, and it could be like a -1/2 even, that's why we have the absolute value bars. But if it's between 0 and 1, it makes the graph more narrow. Questions on that? Or not narrow, more wide, I misspoke. All right, now when A is negative, what happens to the graph? It flips. And yeah, it would be downward or this. So when A is negative, the graph reflects is the proper term. All right, so it's not that it's smaller than 1 or bigger than 1 that it makes it flip. It's if it's negative that it makes it flip. So I think like negative, like down like a frown. When negative things happen, you frown, it will be that way. When good things happen, like positive things, it's like a smile. So that summarizes what we just did. But when in doubt, you could always like play around with numbers in here and see what happens. Like if you don't remember, type it in, compare it to the parent graph. Like, okay, this made it wider and flipped it and all that stuff. So questions? All right, we're almost done. We have a card sort to kind of end it. So one person from each group, you'll come get the cards from the back table, they're paper clipped. You're going to have essentially 4 groups. You're gonna match the standard to the factored to the graph. So at the end, you should have 4 piles of things that all mean the same thing. Questions? Okay. All right, so let's see. Again, you should have 4 piles of things that match each other. So I'm just gonna start with A. Which of these in this column is my factored form of A? E, F, G, or H? Okay, 1 vote for F. Anyone agree, disagree? So let's see. Here, there is a way to go from standard to factored form, but we're not doing that in this unit. That'll be unit 7. However, we did teach you how to multiply this out, because factors, you multiply them by foiling, right? So first, x times x, x squared, outer, you get -1x, inner, +1x, and then last, 1 times -1. These two middle terms do cancel out, because -1x plus 1x is 0, so yeah, it does match what I get for the standard form, so that is true. I'm using colors, I'll kind of make a list over here, which is what you should have for your notes for the answers. All right, and then what graph matches A and F? Okay, someone said I, anyone disagree with that? Did you have to use Desmos for that? Based on the discussion we just had? You don't have to. I understand if you did, because I mean, you should check your answers anyway. But based on the little activity we did, when we subtract a constant from x squared, and that's all that's going on, that just moves the parent graph down one, which is what this illustrates. But again, you could have confirmed in Desmos. All right, so that's my first set. Now, which one matches B for the factored form? Okay, someone said H. Anyone disagree with that? So let's see, for this one, you would have to expand it first before you multiply them. Don't distribute the exponent, please. That means that we're multiplying the base by itself, and then FOIL. So we get x squared, outer -2x, inner -2x, last -2 times -2 is +4. And yes, when I combine these middle terms, I do get that, so that works. That's how you can confirm that the factored and the standard match. And then what graph matches those? Okay, have a vote for J. Anyone disagree? Okay, for that one, I think I would have to type it in and see, because we haven't done left or right yet. We've only done up, down, stretched, compressed, and flipped. But yeah, if you do type that one into Desmos, and you could type in the factored or the standard or both if you want. All right, it does move to the right of the origin, and the vertex is still on the x-axis, so that best matches that one. Good so far? Sorry, I didn't realize how short on time we were. Real quick, C matches what? E, and then what graph? L. So then process of elimination, it would be D, G, and K. So have these answers written so you have them to reference to, but the way we went over it are some strategies to help you find that those are right. Questions, comments, concerns? All right, so whatever you didn't finish for your puzzle piece, you know, do it homework. Maybe prioritize everything from the beginning through 10, since you're taking your mid-unit quiz tomorrow. Oh, and if you could do me a favor and just neatly pile the stuff and paper clip them, I would appreciate it. You can leave it at your desk, it's fine.